Get your answer quickly. Okay, hoping that you have got an answer for this problem. Let's discuss this. Now it says that A moves perpendicular to the river from the point of view of P. Now in the reference frame of P, A is moving perpendicular to the river. So velocity of A with respect to P is velocity of A minus velocity of P. Fine. Velocity of A with respect to P is perpendicular to the river. That means velocity of A actually is velocity of A with respect to P plus velocity of P. Velocity of P is downstream, VR. I told you that P is not moving with respect to river. That means it is moving with river. So velocity of P is VR, the flow of the water, the flow of the river. And the velocity of A actually will be the velocity perpendicular plus velocity of P. Fine. So A is having the two components of velocity. So A will be moving, A has two components of velocity. That means A will be moving something like this. And it says that B on the other side of the river moves downstream. That means B moves straight downstream and meets somewhere here. And as was given in the problem, they meet at the same point during the course of their journey. So maybe suppose they meet somewhere here, and maybe at any, B could start from any point. And they are asking actually the initial distance between A and B. This is what they are asking, this distance between A and B. So let's find the distance between A and B. Now the time taken for A to move on the other side of the bank will be the velocity component which is perpendicular to the river, as we have discussed in the previous problem. Okay, so the time taken for A to move on the other side would be the width upon Vm, because Vm is causing the displacement perpendicular to the perpendicular to the river, and Vm will be responsible for A to move on the other side. Because if A is moving perpendicular to with respect to P, that means this component of velocity of A and P are the same. That's why P is not sensing this motion of A, because with the velocity which A has in this direction, the same velocity P also has. So their distance remains the same in this direction. As A moves ahead, P also moves ahead. So P only senses the perpendicular motion of A. That means in this direction, A is moving with the flow of river, as is the case with P. That's why it seems to P that A is moving perpendicular. But A has its velocity of its own Vm. That means whole of the Vm should be directed perpendicular to the river, and its none of the components should come along the river. Okay? So that's why the y component of the velocity of A will be Vm. So the time taken for A to go on the other side will be d upon Vm. And the drift, by the time A reaches on the other side, there will be some drift. That drift will be time taken. The drift will be time taken for the journey into the x component of the velocity, which is Vr. Fine, this is the drift. And it says that A and B reaches to the same point simultaneously. So during this time, the course of journey, B should have traveled some distance and have got to this point. Now during the same time, that is d upon Vm, B has traveled some distance, and the distance traveled by B would be time of the journey into the velocity component of B. Now B is going downstream, and B also moves with the same velocity of its own, Vm. When it goes downstream, then velocity would be the net velocity, the velocity that it is generating on its own, plus the velocity with which the river is flowing. River will also drag swimmer B. It will help the swimmer B to go downstream. So the velocity with which the swimmer B is going is actually Vm plus Vr. So this is the distance that swimmer B has traveled. Okay, so the distance that swimmer B has traveled is equal to d plus d Vr upon Vm. Okay, so the distance that swimmer A has traveled along x-axis is dvr upon vm. This is dvr upon vm, this drift. And the distance that B has traveled is d plus dvr upon vm. That means swimmer B has traveled a distance d greater than the swimmer A along x-axis. So maybe B has started from this point, and maybe this distance is d, because this is dvr upon vm. So swimmer has started from this point d, and this is also d, right? So this is a right angle triangle, and this you can find out the initial distance between swimmer A and swimmer B. That would come out as d root 2. So the answer would be d root 2. Okay? Pretty easy, isn't it?